Good morning, children. It's me, Mr. E. How are you today? Today I thought I'd give you a treat and let you watch me eat little chocolate donuts right before we do everyone's favorite word problem. Mm-hmm. All right, let's get started. Woohoo! Mm. All right, so right now we're going to solve systems of equations, but we're going to set them up in word problems. So a lot of people have problems with word problems because it's hard to translate the words into numbers, but I'll give you a few tips here for you to be able to do that. So here we go. Let's start. Zoom in here. All right. So the first thing you're going to do is give yourself a pen instead of the eraser. All right. The first thing you're going to do is define each variable. You've got to look in your word problem there and see there's going to be two variables, and they're going to represent two different things. Um, so first, find out what x and y are, or maybe a and b, like right here in the first one. We have 3 apples and 4 bananas cost this much. And 3 apples and 10 bananas cost this much. Well, we have an A and a B. We have two things that cost things, right? We have two things that cost money. So I'd say the A is an apple and the B is a banana. I think that's there. Okay. Then what we're going to do is set up a system of equations. That's what we've been doing this unit. So the system of equations, well, this one is set up really easily. This says 3 apples, so 3 apples and, that word means plus, this and that. And 4 bananas, 4 B's, cost equals 485. There's one equation. The other one is the second sentence. 3 apples and 10 bananas cost $8.75. So there you have your two equations. 3a plus 4b is 485. 3a plus 10b equals 875. So next we're going to do solve division graphing, elimination, or substitution if you want. You won't use that much in the future. Of course, graphing is the easiest. Just plug those two into your graphing calculator. And the Desmos, in fact, I'm going to do that right now. I'm going to go over here to Desmos, D-E-S, Deso, Desmos. Going to go right here. I'm going to show you how we can do that. So it was 3 bananas, we'll just say X, or 3 apples, plus, what was it? Let's see, 3 apples plus 4 bananas is 485. 3x plus 4y equals 3.85. I believe that's correct. 3.85. Oh, 4.85. Okay, 4.85. 4.85. And then the next one was 3 apples plus 10 bananas equals 875. I believe it was, wasn't it? 875? 875, yes. So let's look at here. There's the intersection right there. 0.75 and 0.65. So x is 0.75, or we'll say a, b. is 0.75 and 0.65, I believe it was, wasn't it? 0.75, 0.65, yes. So apples are 75 cents each, bananas are 65 cents each. Oh, there we go, cost of an apple, 75 cents. 0.75 cents. And so I solved that by graphing because I had the equations right there, and I really didn't want to write a lot of things out. So I'm going to use the method that is easiest for me, Desmos. Then the last step here, we're gonna define the solution in the context of the word problem. And that's what that last question was right here. What's the cost of an apple? 75 cents. That's why we set that up in the first place. Excuse me, those donuts. That's why we set those up in the first place, right? So we can figure out the cost of an apple. So there's one that we used graphing with. Let's do this one. The difference of two numbers. Now, the difference is from subtraction. And two numbers, well, probably x and y. And that means, whoa, it's a little bit smaller so that doesn't happen. There we go. So the difference of two numbers. So two numbers, like maybe x and y, right here. X and y. So the difference of those two numbers is 16. X minus y equals 16. Now, it says here the greater number. Which one of these numbers is the greater number? X? Do we know? X or Y? Well, the result, the difference, is positive. So the X has to be bigger than the Y for that to remain positive. If the Y was bigger, then the difference would be negative, wouldn't it? So X is going to be the greater number. So we'll define that greater number. And this will be the smaller number. All right. So the greater number, X, is, that word means equals. 5 less than, that means I'm going to subtract 5 from the next piece, which is 4 times the smaller number. So 4 times the smaller number, 4 times y, 4 times the smaller number, and then less than 5 less than that. There we go. 5 less than 4 times the smaller number. Here's 4 times the smaller number, it's 5 less than that. So here's my two equations right there. I am going to rewrite these and set them up in I'm going to convert this bottom one into standard form, which is what this top one is in. We have an x and y on the same side and the constant on the other side here. So I'm going to subtract 4y from both sides and rewrite it up here. And I'm going to zoom in and get smaller here. So let's see, I'm going to rewrite the top one, x minus y equals 16. And then I'm going to write the bottom one as minus 4y. You know what, I'm going to put x first. X minus 4y equals a negative 5. That's what was left over there. Minus 4y plus x equals minus 5. That's what was left over there. Okay, here's our system of equations. It's set up nicely. I'm going to go ahead and erase all of this because we have equations over here. I'm going to move it over. A little bit more. Okay. Here we go. Well, we've got the same coefficient here, but different signs. So I'm going to multiply the bottom one by a negative 1 and rewrite these all over again. I'll just draw a double line here to show that we're going to rewrite this. So x minus y equals 16, and then a minus x plus 4y equals a positive 5. There we go. So I can eliminate this right here. That goes to 0. And a minus y plus 4y, that's 3y, equals 21. and just divide by 3 to get rid of that. And I have y equals 7. So here's my first. Y is 7. And now I can plug this in to that easy one right up there. X minus 7 equals 16. So I will add 7 to both sides. That gives me x equals 23. So 23 and 7. And the difference of those two numbers is 16. 23 minus 7 equals 16. That's right. And the greater number, 23, is 5 less than 4 times the smaller number. 4 times this equals 28. If you take 5 away, you get 23. That's exactly what we have there. So there, we've checked our answers and everything is perfect. Wonderful. All right, let's go to the next one here. I'm going to just do this one page, I think, and then I'll let you do the next page by yourself. But I'll give you a couple hints maybe. All right, a 100-foot cable is cut into 2 pieces. Let's call those 2 pieces X and Y. And hey, we even know a couple more things about it. It's a 100-foot cable, right? So 100 is, that was equals, cut into 2 pieces, well, let's just say X plus Y. So the 2 pieces together is 100 feet. So there's our first, equation. X plus Y equals 100. And the first piece, well, let's define our variables. We'll just say X is the first piece, and Y is the second piece. Okay. So the first piece, which is X, the first piece is, remember that means equals 18 feet longer than. That's, again, making something longer. That's making something bigger. So it's adding. So we can actually put that right there. 18 feet plus the second. There we go. And we're just going to find out how long each one is. We're going to find out how long X and Y is. So this one's already set up in standard form, ready for elimination. I am going to subtract Y from both sides of that equation. So I'll have X minus Y equals 18. And then I'm going to rewrite my equation so it's nice and neat. X plus Y equals 100. And then X minus Y equals 18. Okay. And look at that. I'm going to erase this since we have them set up. What do we see there? Do we see some variables that have the same coefficient but different signs? Yeah, right here. Whoops. Yeah, right there. Y has a coefficient of 1, and the signs are different. So we can eliminate that right off the bat. So x plus x is 2x equals 118. So let's divide by 2. That gives me x equals, what is that, 59. Okay, so I'm going to take this 59 and plug it into that one. X plus, oh, not x, 59. 59 is x. Plus y equals 100. Let's subtract that 59 from both sides, and we'll see. That goes away. Y equals 41. All right, so the solution, x, y, equals 50, 41. There we go. Okay, last one. Okay, Reagan School is selling tickets to a spring musical. All right. On the first day of ticket sales, the school sold 3 child tickets and 9 adult tickets. So here's our 2 variables. We have adult. We have adult tickets, and we have child tickets. These tickets are made out of adults, and these are made out of children. All right. So we have 3 child tickets and 9 adult tickets for a total of $75. So that one, 3, let's do this in 9 adults plus 3 children. We'll keep them in alphabetical order. Equals $75. That was the total. And then the next one, let's see, the school took in, you know what, I'm going to change colors, just differentiate. The school took in $67, so there's another total. On the second day by selling 8 child tickets. Oh, 8 child tickets, so 8 C, and 5 adult tickets, so 5A. There we go. Well, I don't have the same coefficients here. Don't have the same coefficients here. And they're all the same size signs. They're all pluses. So we're going to have to multiply this. I am going to zoom in and shrink this down. Like that. So I have a little more room. Right. Okay, well, what's going to be the easiest? Let's find a common denominator. Is there a whoa, no, don't do that. Is there a common denominator? Let's see. Is there a number that I can multiply, say, 3 by to get 8? Well, no. Multiply by 2, I get 6. Multiply by 3, I get 9. So that's too big. What about, is there a number I can multiply this 5 by to get 9? Well, no, there isn't. So I can't do an easy multiplication, just multiply one equation. So it looks like I'm going to have to multiply both. Looks like I'm going to have to multiply both equations, and that's okay. That's okay. What would be the easiest way to do that? Well, let's see, is there a number? Let's look at, I'm going to look to eliminate C because it's got a lower number there, 3. Maybe I can multiply. Let's see, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. I'm looking for a number that 8 goes into, but I might have to just go all the way up to 3 times 8. Let's see, 3 times 5, 3 times 6 is 18, 3 times 7 is 21. Yep. So we're going to just multiply both equations by those two numbers. So, all right. Yeah, there's all the room I need. Okay, so I'm going to multiply this equation by 8, which is the bottom number here. Multiply that equation by 8. And then I'm going to multiply the bottom equation by 3. And that's really the easiest way to do it. If you can't think of a number right off the bat that both of these would go into, then just multiply them by each other. Multiply the bottom one by the top coefficient, multiply the top one by the bottom coefficient. And this is what you get. I'm going to do it in a third color. So, and just show this kind of going backwards. So, the first bit, 9 times 8 is 72 adult tickets. And then 9 times 3, oh, I'm sorry, 8 times 3 is 24C. And then 8 times 75 is going to make me break out my calculator. 8 times 75 is 600. Okay, equals 600. These numbers are kind of big, but that's all right. All right, so now over here, I'm going to do 3 times 5. It's 15A. 3 times 8. It's 24C. And there we go. Oh, but what did I do? What did I forget? Let's go ahead and multiply 3 times 67. 3 times 67. 201. So what did I forget to do? We have the same coefficient, but we need different signs. So I should have multiplied the bottom one by a negative 3. There, I'll put that negative 3. And all that means I have to do right now is go back to purple and just change all of these signs. Minus 15. And this is going to be a minus 24C. And this is going to be a negative 201. There we go. So now I have all the right stuff. Let's see, 72 A's minus 15 A's. 72 minus 15 is 57. 57A. This goes to 0. So that equals 600 minus 201. is, I should be able to do that in my head, shouldn't I? But I have a calculator in my hand. $3.99. So 57A equals 399. A little closer. Let's divide by the coefficient to get the single A. A equals, let's see, what is that? 300 divided by 57. 399 divided by 57 is 7. Huh, there we go. Yeah, good. Okay, so the solution, let's see, AC equals 7, and let's plug this back into, let's plug it back into the smallest numbers. How about the first one, this blue one here? A is, oh, let's do the bottom one. Yeah, let's do the bottom one, Let's do the bottom one, smaller numbers, I think. So 5 times A, which is 7, plus 8C equals 67. So 5 times 7 is 35, plus 8C equals 67. Let's subtract 35 from both sides. That goes away, so now I have 8C equals 67 minus 35. Let's see, 67 minus 35 is 32. So the last bit here, I know this is getting a little sloppy. 8C equals 32. Divide by the coefficient. C equals 4. There's the second bit, so 4. There's our solution. All right. Oh, what is the adult ticket price? The adult ticket price, A, was $7. That's what that was. Okay. So there's some good examples for you on how to set up your systems of equations. You're going to look for two separate equations. Look for two ways that those variables are expressed. Once you find the variable, that's step one, you set up your system of equations by looking for the two expressions. And let's take a look over here. Let's see, Caitlin has 27 coins that are all dimes and quarters, and the value of the coins is $4.35. So looky here. Your two equations, well, of course, you got D and Q. Those are variables, dimes and quarters. But your two equations are going to have to deal with, and this is easy when you have money. You have the number of coins. So you have the first equation. I'll just put this. First equation is going to deal with the number of coins. And the second equation is going to deal with the value of the coins. How much are they worth? So the value of the coins is one equation, and the number of coins is the other. So if I had, 4 dimes and 8 quarters, how much is that? Well, it needs to add up to 435. And the total, the number of coins is 27 here, and the total here is 435. So just divvy up your variables as you need right there. We'll figure that out. For the second one, let's see, the rocket coaster, I guess it's a roller coaster. The rocket coaster has 15 cars, some that hold 4 people and some that hold 6 people. And there is room for 72 people total. Okay. Well, here I would say there's 2 different types of cars, 4 people and 6 people. So X, let's see, 4-person cars. We'll call it a 4 car, and X is a 6 car. And there's rooms for 72 people total. So 4 times X plus 6 times Y. The number of people here, 4 person per car, and then 6 people per car equals 72. Let's see, the second one, that's the number of people. So this is the number of people. And what else do we have? Here we have a total number of cars. So now we'll just say X cars plus Y cars equals 15. because there's two types of cars. So this is the number of cars that are on the roller coaster, and then the top one is the number of people who can ride each coaster ride. All right. Well, I'm not going to help you with this. You have to do your own there. But let's look at this last one, and maybe I can give you one final hint. Let's see. There are 13 animals in the barn. Some are chickens and some are pigs. Pigs. And there are 40 legs in all. Oh, legs. Interesting. Well, we have number of animals, and then we have number of legs. And some are chickens and some are pigs. So I think you can set that one up yourself. One equation will be the number of animals, and one equation will be the number of legs. How many legs does each animal have? Oh yes, I'm stretching. Those donuts are taking their toll. Chickens have, that's right, 8 legs, and pigs only have the one. Oh wait, I forgot what planet I'm on. Yes, chickens have 2 legs, and pigs have 4 legs. So 2c plus 4c equals 40 legs in all. There are 13 animals in the barn. There. I hope you got it. I'm not going to give you all the answers. Okay, there you go. Have at it. I will see you next time. So long, children.